So when it comes to measuring variability, just in the same way that we had to treat central tendency differently when we were thinking about a continuous variable versus a categorical variable, the same thing applies here. So the first thing I'll say is that for categorical variables, we have measures of variability, so you can calculate some of these things for categorical variables. We don't tend to use them very, very often, and part of the reason is just because it's not as common that people are using the same measures, so we don't have a lot of common language around there. For example, like a measure of diversity, which is how spread out people are among different racial groups, means something specific to that context because of how we understand diversity in the world, but you wouldn't necessarily use that measure of like how varied the categories of anything are in another context. So I think it's something we're working on, but it's not something we talk about a whole bunch. So when we talk about measures of variability and what I'm going to be talking about today, I'm really talking about measures of variability for continuous variables. They exist for categorical variables, but are less commonly used, so we're going to be talking about continuous. Now, when we talk about variability for continuous variables, there are really two big options here. The first is the range, and the second is the standard deviation. Now, the range you've probably heard of before, and the range is what it sounds like. It is the range of values, and often you'll see it in one of two ways, if not both, right? Sometimes you'll see people present the range by just telling you what is the bottom number and what is the top number. And by bottom, I mean the smallest number, and by top, I mean what is the largest number. So they'll present the minimum and the maximum number. So let's say we have a whole bunch of data like we have here for people's heights, right? Let's say it's height in inches for a whole bunch of students. Well, the range for this one way to present it would just to be say that the minimum is 5 feet and the maximum is 6'5", right? Now, the other way that people present the range is to actually do the subtraction between the two. So in this case, the range would be 1.5 feet or 6.5 feet minus 5 feet, right? And that gives us some sense of just, well, what is the possible difference, total difference that could exist. Now, that's all well and good. The range is a nice thing, particularly when you're working in a context when it's not necessarily intuitive what would be the minimum and the maximum scores. I think a pretty good example of this would be the SAT. Often we want to explain SAT scores to people, but a lot of people don't just remember, what the normal range of scores is for the SAT. So it's often nice for us to be able to describe the range to people so people get a sense of like, well, how high or low is any particular score. Now, the downside of the range, though, is that it's pretty much just defined by the outside numbers. You could have two distributions like this one and this one, which look pretty different, but have the same range just because they happen to have the same upper and lower number. And particularly in cases when you're working with any kind of measurement where maybe getting at least one person having the lowest number and one person having the highest number is actually not uncommon, the range can be a little less useful. I think a good example of this is test scores, right? Or homework scores. Maybe homework scores is a little better, right? You could imagine that it's pretty typical for a homework assignment to have someone that didn't turn it in and got a 0 on it. At the same time, it's pretty typical for someone to get 100%. And if that's the case, if you look across homework assignments, a lot of homework assignments are going to have the same range of values just because they all tend to have a 0 and they tend to have an 100, but it doesn't give you a good sense of the variability between. So the range is nice, but we often don't stop there, though we do present it. The other thing that we will sometimes use to talk about variability is something that we call the standard deviation. Now, the standard deviation is often the first kind of formula that people get to in a statistics class that isn't something that they use in their common vernacular. So we are going to sit on it for a little bit. Now, the standard deviation is just like anything else, a measure, right? It is a number that we have come up with as human beings with a specific formula that serves a purpose for us to be able to describe the variability of data. And this is the way it's calculated with this formula right here. Now, before you look at it and you start to get really stressed about having to memorize it, don't worry about it. I think, over time, if you do a whole bunch of statistics, you will get to the point where like you kind of intuitively know it looks something like that. But for the purpose of right here, it's not as important for you to be memorizing it. But what I do want to do is spend a moment talking about what it's actually doing. Because the standard deviation can be roughly interpreted as the average amount by which units tend to vary from the mean. So let's say we have something where we have a whole bunch of, let's think about something that's not test scores. So we have a whole bunch of people, and for each one of those people, we have a sense of the number of books that they own, right? Well, the standard deviation is a measure of by how many books do people on average tend to vary from the middle average number, right? And the reason for this is this. So you can imagine that, if you don't want to use something like the range, what you'd actually want is some measure of just, in general, how far different points tend to be from each other. But this whole abstract thing I just did in front of my face is not really a formula, right? Nor is it particularly concrete. So in order to make that more concrete, you might say, okay, what I really want, and one way to kind of get at that is I want to see on average, how much do people tend to vary from a certain point? And that certain point could be the mean. So you might say, I want to know on average how much people vary from the mean. That is what the standard deviation basically is. So if you look in the top part of this fraction for this formula, you have the sum of of the distance between each point and the average, which is denoted by the x with the line over it, which we also call x bar, divided roughly by the number of numbers that there are, in the same way that you calculate an average. And again, it's not necessarily important that you memorize like all of what's going on here. And there are reasons why all of this other math stuff is around it that we're not going to go into in this video. But it is important for you to understand that what is going on in this formula is capturing an intuitive thing. It's capturing a human thing that we might want to understand, which is on average the amount that people tend to vary from the mean. And that's the standard deviation. So as a recap, when we're talking about variability for continuous variables, because we don't do it so much for categorical variables, we have two options, range and standard deviation. Where range kind of is lowest and highest number, which can either be just presenting those two numbers or doing the actual subtraction. And the standard deviation is a measure with a more complicated formula that, again, don't need to stress about right now, that roughly captures the average amount by which units tend to vary from the mean.